My name is Dorthe Ravnsbæk and I'm 38 years old and I'm professor in materials chemistry. Overall, my field of study is about linking the structure, the atomic structure of materials to the properties of the materials. And in my research group, we focus on making new materials for rechargeable batteries. So we want to make materials that will give us batteries that are better, of course, and cheaper and safer, and maybe most importantly, batteries that are sustainable. And that's both when we make them and when we use them and when we have to get rid of them again. So in all of our smartphones and tablets and laptops and so on, there are lithium-ion batteries. And in many ways, these types of batteries function really well. But a problem with these batteries is that they are based on some rather scarce resources. So for instance, there's a lot of cobalt in them, which are not only scarce, but also really toxic. And based on the name, you can also tell that there's a lot of lithium in it. And lithium is also going to be a resource that we're going to run out of. So from those perspectives, if we want to keep on using batteries and we want to also put them in our cars and into the electric grid, we really need to develop new materials that are based on other resources. So that could be basing batteries on sodium, for instance, which we can get from the seawater. Or it could be basing batteries on iron, which there is a lot of in the ground. So right now, we are trying to understand disorder in battery materials. So traditionally, crystalline materials have been used in batteries. And in crystalline materials, like in this atomic scale model that I have here, we see that the atoms sit in a well-ordered manner, in a pattern repeating itself basically throughout the material. And what we have found in recent years is that quite often when we use the battery, this order can be lost. And sometimes losing the long-range order will damage the battery performance, so the battery will die. At other times, it actually doesn't damage the battery. And to make better materials or better batteries, we need to understand these details at the atomic scale, right? Because then we can both prevent damaging disordering processes, but we can also maybe utilize this to use some materials that are not crystalline from the beginning.